This portable radio uses 1.5 volt tubes and a 3 volt tube. You can see that the 3V4 is center tap, so from the center tap to either side is 1.5 volts. This is the diagram of the radio, and if the Selenium rectifier needed to be replaced, here it is in the wiring diagram, and this is what the Selenium rectifier looks like. If that needed to be replaced, I would be replacing it with a modern diode, and it would look something like this in the circuit. But before I hooked up the diode completely and turned on the radio, I would need to do some testing, and here is why I'm very careful when I'm replacing a Selenium rectifier with a diode. Looking at the wiring diagram, and if we go through the 3 resistors and go to the highest filtered part of the B+, which is all the way over to the right, we notice that the B+ does go to some plates of the tubes, but notice that we have another connection, and it actually goes to the filament of the 3V4. And then from the 3V4 it goes to the other tubes, and then all the way back down to the return. Looking at the diagram of a Selenium rectifier and a diode, what's missing here, or what is not apparent, is that Selenium rectifiers have a greater internal resistance than does the modern diode. So basically what that means is sometimes, depending on the circuit and the Selenium rectifier that you're replacing, you may need to add a resistor in series with that diode so the voltage is not too high. If you just hook up the diode without testing it, there's a chance that you may burn out some filaments. This is the testing that I do to determine first if I need a resistor, and then what I do to determine what the resistor should be. I just simply use alligator clips from the 2 points in the circuit to a resistor. That way I can quickly change resistors. But before I do anything, I find a tube filament about in the middle of the string, and I put my voltmeter across it and monitor that voltage. Here the voltage should never go above 1.5 volts. I always start with a resistor that I think is too high, and then with the radio turned on, I ease up the AC voltage with my variac and continue to monitor the voltage across that 1.5 volt filament. If the filament increases to 1.5 volts, I stop increasing the variac, and then I take a look at the variac to see where it's at. And if it reads 90 volts AC, that means I need to increase the resistor. If I get up to 120 volts and I have not reached 1.5 volts across the filament, that means I need to decrease the resistance. It has been my experience that in circuits like this, if I need a resistor, it'll be 150 ohms or less. But I still like to start on the high side and work down. Let's say that in this circuit with this diode, I need a 150 ohm resistor. Then the next question would be, what watt resistor should I use at 150 ohms? To determine that, I would look at resistor R8, and if R8 was a 2 watt resistor, minimum I would use would be 2 watts, 150 ohms.